Welcome back. This is video 2 and we're going to start with question number 17. Read through the question and come back. Alright, so this question, if I see coordinates and I see a ratio, I'm doing partitioning. And I promise you partitioning is going to be on that EOC, so make sure you really understand what we're doing in this problem. Alright, so the concept is this. We have a line segment, JK. We have this line segment divided in a ratio of 1 to 3, which means there's going to be a total of 4 parts. Now, if I take my line segment, I divide it into 4 parts. Let's take a look. I'm going to put kind of a middle point here, and a point on the left, point on the right. Okay, so imagine these are 4 equal parts. Now, if I'm dividing in a ratio of 1 to 3, I want to put a point somewhere on my line segment that's going to cut it for one even section on the left and then 3 even sections on the right. If I put my point right here, okay, now I have 1 section on the left and then 3 sections on the right. And when I think about my K value talks about what fraction of the whole distance have you traveled to get from J to your partitioning point. In this case, I've traveled 1 out of a total of 4 even pieces. So I've traveled 1/4 of the whole distance. Now this question is a little bit trickier because it's asking you for 2 possible locations for your point. Now let's take a look at how we can figure out the other location. Again, I'm going to draw out a line segment, JK. I'm going to divide it up into 4 even parts. All right, here are my 4 even parts. And now I want to put a point so that, again, it's in the ratio of 1 to 3, but I'm going to have 1 piece on the right and 3 pieces on the left this time. So I'm going to put a point here. So now I have 3 on the left, 1 on the right, so it's still in the ratio of 3 to 1. It's just that my point is in a different location. It's 3 even sections away from J. So when I'm thinking about my K value, what fraction of the distance I'm going to travel from J to my partitioning point, I've now traveled 3 out of a total of 4 even sections. So what I'm going to be doing is I'm going to be doing this partitioning problem twice. Once using a K value of 1/4, and then another time using a K value of 3/4. That's all you do different if they're asking you for 2 possible locations. All right, so I'm going to go ahead and I'm going to plot this line segment JK so I can visualize where this line segment is on my graph, what it should look like, and then I'm going to be able to test at the end if the 2 coordinates that I came up with are collinear with points J and K. Okay, so here I've plotted line segment JK, and I'm remembering that any points I get need to be along this line somewhere so that it looks like it's 1/4 of the way and 3/4 of the way from J. All right, now some of you can do this visually. I'm going to go through the formula. I love the visual way, but I'm just going to go through the formula. Okay, so here I've rewritten the diagram. I've labeled in my 2 points, M1 and M2. Those are the 2 partitioning points. They like to call them M in this problem. So I'm going to be looking for the red partitioning point, M1, which is using a K value of 1/4 first. And then I'm going to do the whole thing again with M2, which is going to use a K value of 3/4. So this is how my visual is laid out. Remember your partitioning formula. Write it down on your papers. Do it at least a couple of times if you're trying to memorize this. And now let's get started. Let's plug things in and let's work it through. All right, so starting with XP. Okay. All right, XP, we have XP missing. That's the partitioning point. It's missing. We have X1, which is our starting point, -4, plus K, in this case it's 1/4, times our X2, which is 8, minus our X1, which is -4. The 2 minuses, automatically I circle them, they make a positive. And now we move on to the next step. All right, always do parentheses first. PEMDAS tells you work with the parentheses first. So I'm going to rewrite XP equals -4 plus 1/4 times 8 plus 4, which is 12. The next step is where everyone makes a mistake. We are going to be multiplying 1/4 times 12 first, and then we're going to be adding it to the -4. 1/4 times 12, that's the same thing as doing 12 divided by 4. So 1/4 times 12, you get 3. So I'm going to bring everything else down. XP equals -4 plus 3. -4 plus 3 is -1. So -1 is my x coordinate. Let's do the same thing with y. Okay, so y. My y1 value is 11 plus k. It's the same 1/4 because we're working with point M1 first, so we're only using a k value of 1/4 times y2, which is -1, minus y1, which is 11. Okay, so now simplifying the parentheses first. Yp equals 11 plus 1/4. -1 minus 11 is -12. All right, now we can go ahead and multiply 1/4 times -12. So Yp equals 11. 1/4 of -12 is a -3. It's like -12 divided by 4. And now last step, Yp equals 11 minus 3, which is going to be 8. So this is our coordinate, -1, 8. This is point M1. That's the first partitioning point. Now we're going to go ahead and graph it and make sure we can work it out. All right, so here I've graphed that point -1, 8, and yes, it's collinear with j and k, so I know that I did something correct. All right, if it was not on this line, I would know I did something wrong. And it does look like it's about 1/4 of the way from j to k. So in my head, I think this is working out pretty well. Now let me do the whole thing again, except we're going to change our k value. So let's go back to our work. All right, now taking a look at our work, let's see what's going to change. I'm going to erase everything here. Okay, and the only thing that's going to change in our problem, our x1 or x2, none of that's going to change. The only thing that's going to change is our k value. Okay, so you can rewrite this all again, but just know the only thing that's going to change is your k value. Now our k value is going to be 3/4. So we're going to do this again with 3/4. Pause the video, try it out for yourselves, and we'll come back. So your answer should be 5, 2. Did you get it right? If not, stop the video, pause it right here, look at my work, and then check it against yours to see maybe where you went wrong. Okay, so let's go ahead and plot 5, 2, and let's see if it's collinear. All right, so here it is. I've plotted M2, which is at 5, 2, and all of the points are collinear. So if you take a look, visually, it should make sense to you. We have from J to M approximately 1/4 of the whole distance, and then from J to M2, it looks like 3/4 of the distance. So it's still in the ratio of 1 to 3. All right, so that ends this video. We're going to move on to the rest of the questions in the next video. I almost forgot. Let's take all the glory. Let's go ahead and mark off what's correct. We did all that work. So back to your question, both locations for our point, we have -1, 8, so you're going to check off B, and then also 5, 2. So you're going to check off G. So the two correct answers, B and G. All right, now go ahead and look at the next video.